Okay, so we're going to continue on developing some equations, some derivatives of functions. So the way it's going to work is I'm going to work one and then you're going to work one that's similar to it but slightly differently. So we've done x squared, we've done x cubed. We haven't done x, but should be easy. It's too easy, almost like that's it. So I'm going to work through this one, and then you're going to work. You have 1 over x squared on your sheet. I made the test up yesterday. Made copies of it, so I'm all ready for next Thursday. So you have the function. You write the function as a function instead of just of x plus delta x. So what we do is we take the original equation, substitute x plus delta x in for x. You take the definition of the derivative, the limit definition of the derivative, which is the limit as delta x goes to 0 of f of x plus delta x minus f of x divided by delta x, which we got from just looking at a general case of a function and picking a point slightly to the right of the original point and just using the definition of the slope, which we've used forever. Okay, so then once you've written the definition, then you just plug in. So we got the limit, delta x goes to 0 of f of x plus delta x, which is 1 over x plus delta x minus f of x, which is 1 over x. And we divide by delta x. So again, if I let delta x go to 0, you end up with an indeterminate result. So we somehow got to manipulate things. And the first thing we always do is simplify. So what do you think we might do to simplify? How about combine two terms into a single fraction? That sounds like a good idea. Let's try that. So what you would do is you'd find a common denominator. Actually, here's a little sidelight. If you have a over b plus c over d, that's equal to AD plus BC divided by BD, right? So you kind of do like a cross multiplication, AD plus BC divided by the product of those two. It's the same as finding a common denominator, but it's a little, so that works if you have two fractions. So in our case, A is 1, so you get 1. B is D is x plus. Actually, we're subtracting here, so let's put a subtraction in there. If that's the case, then there's a negative sign right there. Okay. So then we have minus b, which is x plus delta x times 1 divided by x times x plus delta x, all divided by delta x. Okay, so we haven't finished our simplification. As you can see up here, what's going to happen is this is going to cancel out with that. If you multiply it out, you'll have negative x. Here we'll have positive x minus minus delta x. So what's left over when you simplify the numerator there is just negative delta x. So I skipped a step there in multiplying it out, but hopefully you can see that all this simplifies to negative delta x. And then you have the denominator, and then you have the other denominator here, all divided by delta x. Now, the question is, do I multiply by delta x here, or do I divide by delta x to handle this? Well, what I would normally do is create two fractions. So here's a little sidelight. If you have a divided by b divided by c divided by d, what you do is you take the reciprocal of what you're dividing by and change it into a multiplication problem. So we're going to do the same thing here. So this is so instead of dividing by the fraction c over d, we keep writing b there. I don't know why I keep doing that. D. So you take the reciprocal of what you're dividing by. So we're going to do the same thing here. So what we'll have is the limit as delta x goes to 0 of negative delta x divided by x times x plus delta x times, take the reciprocal of that, which is 1 over delta x. So that's our simplification. Okay, it's still indeterminate at this point, but now we're going to divide out delta x. Because we have delta x in the numerator, we have delta x in the denominator. So what we end up with is negative 1 over x times x plus delta x. So that's our divided out. And now you've eliminated the indeterminacy. So I've eliminated indeterminacy. And C, there we go. Something like that. Hopefully that's a word. So now all we have to do is we just set delta x equal to 0. So then what we have is negative 1 over x times x plus 0, which is negative 1 over x squared. So what we can say is if f of x equals 1 over x, then the derivative f prime of x is equal to negative 1 over x squared. Okay, so now you guys, if you pull out your sheet, I want you to do 1 over x squared. Okay, it is a little harder than this. So we'll stretch you a little bit. Some of you will get it, some of you won't. So what I'm going to do, actually, make sure everybody's finished copying that down. What I'll do is I'll go back 2 pages, put a blank page, I'll give you a few minutes to get a head start, and then I will, and you can ask me questions during that time, and then I'll catch up, let you catch up a little bit, or I'll catch up. So in our case, f of x equals 1 over x squared. Okay, that's where we're starting from. So you'll end up with 1 over x plus delta x squared, and then you'll have to, at some point you're going to have to multiply it out, just like we did. If you look back at the front page, we multiplied out x plus delta x times x plus delta x and got x squared plus 2x delta x plus delta x squared. So you can kind of look at your front page and then you'll end up with something like this, and then you have to find a common fraction. So you'll cross multiply just like you did here. It's a little messier. once you create the fraction, just like in this one, you'll keep simplifying, and then once you simplify enough, you'll be able to cancel or divide out the delta x. Keep going. Don't worry. Oh, you're stuck? Let me see what you got so far. Okay. Okay, so you've got, yeah, what you've got is eraser, yeah. So what you have is x plus delta x quantity squared. So then this, when you multiply this out, it'll become x squared plus 2x times delta x plus delta x squared using FOIL. Okay. Let's see what you got. Okay. Okay so far. Wander this way. And let me turn around again. Oh, is this the one you're working on or the one that's on the board? Okay, here's yours. Okay, gotcha. So this is f of x plus delta x. Make sure you put the delta x there, and then you'll plug it in to the function. So instead of having 1 over x plus delta x, like there, you'll have 1 over x plus delta x quantity squared, and then you'll subtract 1 over x squared. See how fast you guys see who the fast people are. Okay. So there's the first part. Define f of x plus delta x, and then plug into the limit. Now the next step is our simplifying step. So I'll get you started on that if you're still stuck. I'm going to actually wait to multiply this thing out. So I've done just like the previous problem, cross multiplied. So you get You get 1 times x squared minus 1 times x plus delta x quantity squared divided by the product of these two divided by delta x. And then what you want to do is you want to multiply out the numerator at the top, and then simplify that by canceling out the x squareds. So once you have done that, once you've eliminated the x squareds, you'll have two terms left. You'll have negative 2x delta x and negative delta x squared. At that point, if you look at what we did, so it's basically what we just did here. So let me put this the other one we just did on here. So what we did here, so this is this part. So then in this case, we eliminated the x. Here we're going to eliminate the x squared. You're not just going to end up with delta x here. You'll end up with two terms. You'll take the reciprocal of this, multiply it by there, and then you'll be able to eliminate the delta x. You'll be able to divide it out. So we're on this step. So you need to get to that step if you. So again, multiply this thing out. Delta x plus delta x squared. Okay, cancel out delta x's. Okay. So at this point, you've eliminated the indeterminacy by canceling, by dividing those out. So now you can, because you don't have the indeterminacy anymore, you can stick in delta x equal to 0. And you get that, which is correct. You just have to simplify it because you've got an x in the numerator, x to the fourth. So just make that x cubed. And then you've got the answer. That's good. Yeah, something's wrong. Let's see here. So those canceled out. That canceled out with that. There should be this is delta x squared.
Okay.
Well, actually, let's see. Here it's delta x squared. You factored out a delta x. So what's left here is, yeah. So this would be delta x.
Okay.
So we had delta x squared. Now we factored out delta x. So this is delta x. So when you let delta x go to 0, this is going to go to 0, and you're just left with that.
Okay.
There should be a minus sign somewhere in here too, because you've got the negative sign here. So this should be negative, and this should be negative.
Okay.
Okay? Otherwise, you're okay.
Right here, can you cancel those out since?
Well, you have to cancel out this and that one. You have to, if you have a single term in your denominator, and to be able to cancel this out, you have to cancel it out in every part of the numerator, not just one place. So this will disappear, and this will become just delta x.
Okay.
So the answer, if anybody's gotten to that point, is negative. What is it? It's negative 2 over x cubed. Is that right? Yeah, I think so. It should be. Okay. The good news is that once we derive these equations, we don't have to do this anymore. So it's only for this week, or this week and part of next week. So I multiplied this out, which is, if you multiply this out, it's x squared plus 2x delta x plus delta x squared, but there's a negative sign, so you have to apply it to all this. So those are canceled out, go to 0. And then what do we have? So it's a limit. Delta x goes to 0. So we've got negative 2x delta x minus delta x quantity squared divided by x plus delta x squared times x squared. I'm going to go ahead and do this in two. So I've eliminated. They'll take the reciprocal of that, which is 1 over delta x. And this delta x cancels out with both of these delta. You have to divide each one of these by delta x. So this is the simplification. Now the next step is the dividing out. I'm dividing out the delta x that's in the numerator and the denominator. So you end up with negative 2x minus delta x, all divided by x plus delta x quantity squared times x squared. And then the final step is to, because I don't have an indeterminacy anymore, if I let delta x go to 0, I don't get 0 over 0 anymore. So I'm going to say let delta x equals 0. Because we said as long as if you evaluate a limit and you get a number, then that's the answer. And I don't need to put that in there. So we're just letting delta x go equals 0. So that leaves negative 2x divided by, well, let me go ahead and put in here, minus 0, because that's 0. And then you get x plus 0 squared times x squared. So that's negative 2x divided by x to the 4th. And that simplifies down to negative 2 divided by x cubed. And that's your answer. Now let's just look at the previous problem. We had that if we had f of x equals x 1 over x, the derivative was negative 1 over x squared. And right now we've said that if f of x equals 1 over x squared, the derivative is negative 2 over x cubed. So if we go back a couple of pages here to the stuff we did last time, notice the derivative of x cubed was 3x squared. So to take the derivative, we just took the exponent 3, multiplied by that constant, reduced the exponent y1, and that gave me the derivative. If we look at the derivative of x squared, wherever that was, if I did that somewhere, maybe it's on your paper. We did that, we got 2x. Now, here we're doing 1 over x and 1 over x squared. Let's look at that. If I were to rewrite this as x to the minus 1 power and this x to the minus 2 power, so I've changed it from I've just moved it to the numerator and changed the exponent to the negative. So if I apply that rule that I just thought of, if I take the exponent, which is negative 1, and I then reduce the exponent by 1, so it becomes negative 2 instead of negative 1, you can see that the rule applies here. If I use what I end up with, if I use the rule, I'd get negative 1 times x to the minus 2, which is the same as negative 1 over x squared. And here, if I take the exponent negative 2, use that as the multiplier, reduce the exponent by 1, make it 1 more negative, it'll be negative 2x to the minus 3 power, which is the same as negative 2 over x cubed. So it seems like we're coming up with a rule. There is a rule. I think it's in the next section, but that's the whole idea here, is we do some examples and then we kind of come up with this. We observe a pattern and then we have a rule. So we don't, if we wanted to know what is the derivative of x to the 4th, we wouldn't go through all this trouble. We'd just say it's 4x cubed because we have a rule at this point. Okay, so we've done all these. Now, so the next one we're going to do here is the square root of x. and you guys get to do 1 over the square root of x, I think. Okay, so that's kind of a combination of two things. So let me do this one. So we have f of x plus delta x equals the square root of x plus delta x. Again, all I'm doing is taking the original function, plugging in x plus delta x for x. We say the derivative is defined as the limit as delta x goes to 0 of f of x, oh, here comes the rain, minus f of x divided by delta x. And then we plug in what we know to be f of x plus delta x, subtract f of x divided by, and I forgot the limit part, delta x goes to 0, delta x. Okay, so this is where rationalization comes into play, because we can't use the dividing out anymore, but we do have a square root function. It's a little bit different than we had before, but not that much different. So we're going to use rationalization here to remove the indeterminacy. So we're going to multiply by the square root of x plus delta x plus the square root of x, and divide by the square root, pardon me, got carried away with my square root there. So I'm going to divide by the same quantity, which is x plus delta x minus the square root, plus the square root of x. Okay. So this is the problem child here. So I changed the sign to plus. Multiply and divide by the same thing. So the next step is we're kind of simplifying it, I guess. So using FOIL, when you multiply x plus delta x, square root of x plus delta x times the square root of x plus delta x, you get x plus delta x. When you multiply the inner and the outer, they cancel out. And when you multiply the last, you get negative x. So the square root of x times the square root of x is x. You've got the negative sign. So that's what the numerator becomes. The denominator stays the same. So we have delta x times the square root of x plus delta x plus the square root of x. And the simplification part is eliminating well, actually we're eliminating x, which is what we want. So we get delta x divided by delta x times the square root of x plus delta x plus the square root of x. These cancel out, so we're just left with 1 over the square root of x plus delta x plus the square root of x, and then we let delta x equal 0 because we've removed, this is removing the indeterminacy. So by doing that, we just have 1 over the square root of x plus 0 times, or plus, sorry, plus the square root of x, which is 1 over 2 times the square root of x. So what we can say is that if f of x equals the square root of x, f prime of x equals 1 over 2 times the square root of x. So the question is, does the formula work that we just came up with? Well, again, what we would do is we take the original equation and we rewrite it as a fractional exponent. So we don't have it as a square root. So let's just try it out and see what happens. So if we just say f of x equals x to the 1/2 power, that's what the square root of x is, then if I thought what f prime of x was based on my previous experience, I'd take the exponent and I would reduce the exponent by 1. So 1/2 minus 1 is negative 1/2. That's equal to 1/2 times 1 over x to the 1/2 power, which is the same as 1 over 2 times the square root of x. And that's what we got. Okay, so the thing we came up with, the expected formula works for fractional exponents. Doesn't have to be a it doesn't have to be an integer exponent. I lost my coffee cup here. Okay, so you guys are going to now try. What time is it? 8:32. Oh, we're moving along. So go to the back page. So try that one. It's kind of a combination between one we just did on the paper and what we just did here. So give it a try. So I'm going to add a page here. I'll give you some of you guys a chance to try it yourself. So we're doing 1 over the square root of x. And you probably can figure out what the answer should be based on, what you would do is change that to x to the minus 1/2 power. So the answer is negative 1/2 x to the negative 3/2 or something like that. So Margaret, you're not a marching band, are you?
No.
Yeah. So do you have concert band?
Yes.
Oh.
So I'm in the wind ensemble.
Oh, you're in the wind.
And you can choose to. I tried to do all 3
Yeah.
freshman year, and it was a disaster.
But you are still playing.
Yes.
It's not like you're not playing for a couple of months.
Yeah.
Okay, I was curious how you kept your lip in shape. I did check on. I was curious, and I've always wondered what the difference between a baritone horn and a euphonium was. So I watched a video last night on that. Because
it kind of phase you up. You do a baritone in middle school.
Oh, you do?
When you get to high
okay.
school.
Yeah, because when I was in the band, nobody had a euphonium. They pretty much played baritone.
Yeah.
But it's the same as. Did you start as a trumpet or did you start as a baritone?
I started so we moved here in 6th grade, and everyone picks their instruments at the end of 5th grade.
Yeah.
And I was like, I'm gonna be a flute, but she's like, we have too many flutes. Why don't you try the baritone?
Oh, okay.
Kind of complete opposites. So I just started on the baritone.
Okay. Yeah, because a lot of times people start on the trumpet and then they need somebody to play that particular part. So, you'll have to bring it in someday. I'd like to see it. Is it a 3 or 4 valve?
Well, so the one at home I bought in middle school, so it's technically a baritone. It's got 3 valves, but the one at school has 4 valves, so I could bring that one.
Okay.
It's a euphonium.
Okay. Yeah. Anybody need a little push in the right direction? Are you waiting for me to? Yeah, I think that's the right thing. I think you've got to put it as combine the two fractions first, and then after that you can use rationalization. So I think that's the way it goes, if I remember correctly. So do like the 1 over x squared or 1 over x until you get to a point where you've got just a numerator in the denominator. And I think then you can use rationalization. Normally you would use dividing out. Yes, I think you can, at that point, what I would do is take the reciprocal of this. Well, so you'd have the x squared here, then multiply by the square root of x plus the square root of x plus delta x in both the numerator and the denominator. Okay. And then I think it'll work out. This is where people's algebra skills get tested. Okay. Yeah, it was funny the other night. It was a practice, and I've been practicing at home. And there's two pieces I have to play first trumpet on, and I have to play a uh, a G above the staff, and then an A, which is the top of my range. And so um, I'd been doing it at home, and I kept my lip just ran out of steam. You know, you give it a few seconds to recover, and then I could do it. But you've got to keep playing because you're the melody. And then so I got to practice, and I don't know what it was. It's like the adrenaline of I didn't want to let him down, and I had to do an A as well on one of the pieces, and I was like, so it was like yes, success. So what I did here, just plugged in f of x and f of x plus delta x. I combined these two into a single fraction. Then I took the reciprocal of my denominator here, so that's where the delta x here comes from. So you get x minus the square root of x plus delta x divided by delta x times this stuff. And then at that point you have to use rationalization. So I'm multiplying by square root of x plus the square root of x plus delta x instead of minus. And at that point, when you multiply out the numerator, you get x minus x plus delta x. So these become x, these become negative x plus delta x, and the inner and outer drop out, and the denominator stays the same. And I'm not going to multiply out the denominator. Some of you may have done it, but I'm just going to do it not until I set delta x equal to 0 am I going to actually do anything. Okay, so these cancel out, and what I'm left with is negative delta x. But that negative delta x can then cancel out with that delta x. So my final simplified expression is going to be the limit as delta x goes to 0 of negative 1 divided by, sorry about that, that's not very good. So what I have left is the square root of x times the square root of x plus delta x times the square root of x plus the square root of x plus delta x. And then you let delta x equal to 0. And what that leaves is f prime of x equals negative 1 over the square root of x times the square root of x times the square root of x plus the square root of x. Okay, so this goes to 0, this goes to 0. So the square root of x times the square root of x is x. So you get negative 1 over x times, in this case, when we add them together, we get 2 times the square root of x. And x times the square root of x is equal to x to the 3/2 power. So there's a 2 right there. So you get negative 1 over 2 times 1 over 2 x to the 3/2 power. And again, if you take the original function f of x, which is 1 over the square root of x, that's equal to x to the minus 1/2 power. So if I were to think what it should be, it would be the exponent, negative 1/2 times x, and reduce the exponent by 1, that would be x to the minus 3/2 power, which is exactly what I got. So all of these examples are proving that the formula to take the derivative of a polynomial, or just a not a polynomial, but just a x raised to any power, is just you take the value of the exponent and multiply by the original expression with the exponent reduced by 1 in the negative direction. And it all comes down to using the limit definition for the derivative, simplifying it using algebra, ultimately eliminating the indeterminacy. Once you eliminate the indeterminacy, you can just let delta x equal 0 to evaluate the limit. And so anyway, I'm not going to, well, yeah, hold on to this. We'll come back and do the last one's easy, but I want to start on something. The last one that we're going to do here is the trig function. So I'll work through this with you. You won't have to, I don't know if you have to do one for homework or not, but so what is f of x plus delta x? So let me see here. Evan. Yep, sine of x plus delta x. So the derivative of the sine is going to be the limit as delta x goes to 0 of the sine of x plus delta x minus the sine of x divided by delta x. Okay, so now we're completely something new. Somehow we've got to remove the indeterminacy, and ultimately we'll end up using the squeeze theorem, but we have to get to that point. So does anybody have any idea of what I might do? Think back to trig. You don't have to know, I mean, I don't expect you to memorize the formula, but do you remember there's some formulas? So if you have, well, yeah, if your book might have this in the front, sometimes they do, sometimes they don't. So there's a trig identity that we can use. So what kind of trig identity, if you have your book here, if you don't, that's okay. Look on your neighbor. So what we have is sum and difference formulas, double angle formulas, power reducing formulas, sum to product formulas, product to sum formulas. So does this thing here look like anything? Yeah, it's a sum. So we want to change it. So if you have this sheet of paper, I'm just going to write out exactly what it says. It says that the sine of u plus v equals the sine of u cosine of v plus cosine of u sine of v. In our case, u is x and v is delta x. So if we wanted to rewrite the sine of x plus delta x using this formula, we'd have the sine of x cosine of delta x plus the cosine of x times the sine of delta x. Okay, so that's what we're going to do is we're going to plug that into here. So let's see what we got. We get f prime of x equals the limit as delta x goes to 0. And again, if you set delta x equal to 0, you get an indeterminate result. Okay, so let's see what we get. Sine of x cosine delta x plus cosine x sine delta x minus sine of x, all divided by delta x. Okay, we haven't eliminated everything yet, so it's still indeterminate. You know, if we let delta x go to 0, you'll have the cosine of 0, which is 1. So you end up with, you end up with the sine of x, which cancels out with this sine of x. And this one, if you let delta x go to 0, you get the sine of 0, which is 0. So you can still get 0 over 0. You haven't eliminated the indeterminacy yet. So we've got to do something with the stuff in the numerator to make this thing work. So anybody? Well, let me write the two squeeze theorems down for you. So the two squeeze theorems are that the limit as x goes to 0 of the sine of x divided by x equals 1, and the limit as x goes to 0 of 1 minus the cosine of x divided by x equals 0. So is there any way we can group any of these elements together to get something that kind of looks like that? Either it doesn't have to be x, it can be delta x as the argument. So if we group these two together, is there anything we can factor out? No. How about if we group these two together? Is there something we can factor out? Yeah, the sine of x. So what we'll do is we'll group this with this. Okay, so we got the limit as delta x goes to 0. So what we end up with is the sine of x times the cosine of x, or cosine of delta x minus 1. So that's these two. I've combined them and factored out the sine of x. The second term is just the cosine of x sine of delta x, all divided by delta x. And what you can see is that this is basically that, with the argument being delta x, and this is the sine of delta x over delta x. So I can use this one for that part of it. So, you know, what I'm going to do is I'm break it up into two limits so it's a little easier to see. So sine of delta, the limit is delta x goes to 0 of the sine of x times the cosine of delta x minus 1 over delta x, and then plus the limit as delta x goes to 0 of the cosine of x times the sine of delta x divided by delta x. So, you know, as far as the limit is concerned, these don't involve delta x, so you could take them outside of the limit if you wanted to, and you could do the limit of this. The limit of this is 0. So using the squeeze theorem, what we end up with is the sine of x here times 0. Actually, minus 0, I guess. Yeah. I mean, this is 1 minus cosine of x. This is cosine of x minus 1. But so you'd end up with, negative 0, which, that's still 0. And then the second part, this goes to 1. So what you're left with is cosine of x times 1. So the final answer is the cosine of x. So what we can say is if f of x equals the sine of x, then f prime of x equals the cosine of x. And this fact has huge implications relative to physics and engineering. The fact that because you can see if I take the derivative of the cosine, you can go through the same procedure using a different trig identity. It turns out the derivative of the cosine is negative the sine. And so as you take multiple derivatives, you go sine, cosine, minus cosine, and it goes through this loop of it repeats as you take multiple additional derivatives. So I'm just going to write this down. We're not going to derive it unless it's a homework problem, and I can't remember if it is or not. So if f of x is cosine of x, it turns out it's negative the sine of x. Derivative of the cosine is negative the sine of x. And that's because the cosine trig identity has a minus sign in it, and that's where that comes from. So I'm going to assign some homework for you here in this section. We got a few little things to cover, but I'm going to go ahead and assign it today. Well, what is today? Friday. Yeah, next Thursday's the test, so we'll do Friday. So let me write that in my book. Did I bring my book? I don't think I did. Oh, well. The other thing we're going to learn how to do is we've learned how to take the derivative, which is the slope of the tangent line. The second thing is to come up with an equation for the tangent line. So once you can calculate the derivative, you can calculate the slope at any point on a curve. And if you know the slope and you know that point, because that's where you're plugging in x equals something and y equals something, well, just x equals something. And so we're going to be able to plot the tangent line to the curve, and that's nice because you can check your answer and make sure you did it right, because if you plot the curve and you plot the equation of the tangent line, then you'll get something that kind of looks like that. You see how the red straight line just touches the red line, which is the original function, and the dark red line is the tangent line. So we'll do that on Tuesday, since we are off Monday. So it's Labor Day. So I think we'll just stop there for today. We'll stay in here for physics. I'm pretty sure nobody's coming in today. Cross our fingers. So keep your paper. What we'll do on Monday is Tuesday, first thing we'll do is we'll finish that one problem, and then you can hand it in.